of radium is converted to radon. So this is a 88, a radium, and 226. But when actually by emitting alpha ray, this radium is converted into straight away into isotope of a radon. So radon 80, 6 and 222. So radium is converted into radon, and then it is actually accompanied by star. But in your plus 2 book, whenever a mass number is accompanied by star, it is understood that it's an isotope. Still it is an excited state, but after which a gamma ray is emitted, then it reaches the stable state. Then it reaches the stable state. Then it reaches Rn86, Rn222. So this is a mass energy equation. So this is called alpha decay. Then after seeing this alpha decay and beta decay and gamma decay, straight away now we will go into the topic of radioactive law of disintegration. This is another important derivation, can be asked in 5 marks. Radioactive law of disintegration. So whenever a radioactive substance undergoes a disintegration, the number of atoms goes on decreasing. Suppose if a child eats an apple kept in a basket, so in a basket 10 apples are there. When a child eats one apple in 5 minutes, and at the completion of 10th minute, how many apples will be there? Within the 10th minutes, so within the first 10 minutes, the child would have completed by eating 2 apples. The remaining apple will be how much? Can you tell me? 8 apples. So at the completion of 10th minute, the number of remaining apples present in the basket will be 8. So 8 is the number of atoms present at that instant of 10th minute, correct? The same way, if the number of atoms in the radioactive substance is equal to n naught. So n naught is the number of atoms initially present in the radioactive substance. So if a dn number of atoms undergoes a disintegration in given time dt, and you can also say n is the number of atoms present at that instant of time. So I can say that the rate of disintegration is directly proportional. What is the rate of disintegration? dn by dt is directly proportional to the number of atoms present at that instant of time. But if you want to equate it, you have to introduce one concept. dn by dt is equal to minus lambda into n. Why minus lambda into 10? The presence of minus indicates number of atoms goes on decreasing during the process of disintegration. So I can say dn by n is equal to minus lambda into dt, minus lambda t. And after, when you go for integration, you will get a log to the base e of n is equal to minus lambda t plus c, minus lambda t plus c. So this is minus lambda n. Actually you get it n into minus lambda is equal to dt. And now you can at the starting of disintegration, n is equal to n naught, correct? And t is equal to 0. At the moment you start the disintegration process, definitely t will be equal to 0, and the total number of atoms present initially will be n is equal to n naught. So when you substitute this condition in the main equation, it then becomes log to the base e of n naught is equal to c. So you can substitute in the main equation, log to the base e n is equal to minus lambda t plus log to the base of e n naught. Then you can say log to the base e of n by n naught, and the right hand side expression can be expressed as a power of exponential minus lambda t. So it should not be log. So n by n naught is equal to e power minus lambda t. So then you can write the n is equal to n naught of e power minus lambda t. So this indicates that the number of atoms disintegrating in a given radioactive element in an exponential process. Then you can draw a graph. So the number of atoms disintegrating in a disintegration process in a given radioactive substance varies, taking place in an exponential way. So this is how you can able to draw a diagram. So the number of atoms present initially in the disintegration process can be denoted by letter n naught. So now the decreasing quantity, this decreasing process is taking place, and the decreasing process is varying in the exponential. That's why I am just drawing here. This is a line which does not touching the x-axis at all. Then in a given time t, in a given time t, the number of atoms decreased by half. In the second twice the time t, it becomes n naught by 4. And then third time, at a time 3t becomes n naught by 8. So from which you can able to understand that the number of atoms decreases, number of atoms are decreasing in an exponential directions. And also from the graph you can also understand that any number of atoms which are taking infinite number of time to decrease to entire quantity to become 0. Suppose 10 atoms are there in a given substance, and what is the time taken by all the 10 atoms to decrease 0? You cannot able to calculate. That's why I am saying in general, any number, all the radioactive substance will take infinite amount of time to decrease its number of atoms to reach 0 during the disintegration process. And next we will move on to the half-life and the mean life periods. So why should we study the half-life and mean life? If all the radioactive substances have got equal lifetime, then how to distinguish that which is the best and which is the worst? Suppose if all are studying, if you people are all are studying and taking first rank, then how come I can able to distinguish? Then I have to fix some sort of I have some criteria. Okay, based on this criteria, and you are good, so I can call you a very good boy and you are a very good girl. So same way, in order to distinguish the radioactive substances, provided they have an infinite amount of lifetime, then I have to introduce another two important concept called half-life and mean life period. So the first one is called half-life. The time taken by one half of a radioactive substance to undergo a disintegration is called one half-life period. Time taken by one half of a radioactive substance to undergo the disintegration. So we can say n is equal to n naught of e power minus lambda t is the law of final expression we have derived under the topic of a radioactive law of disintegration. At a time t is equal to t half. So what happens? The number of atoms n is equal to n naught by 2. So everybody can understand. So substitute that n naught by 2 is equal to n naught of e power minus lambda t power half. So these two can be cancelled. N naught can be cancelled. So log to the base e2 is equal to simply lambda t half. Our aim is to calculate lambda only t half. So t half is equal to log to the base e2 by lambda. Then how will you express log to the base e2 in terms of log to the base of 10? So t half is equal to log to the base 10 of 2 into 2.3026 by lambda. When you multiply log 2 under 2.3026, you will get t half is equal to 0.6931 by lambda. So this is a final expression for calculating the half-life of any radioactive substance. Then we can go for mean life. What is the mean life? Suppose in a family 5 people are there. And for example, a parent gives birth to 5 child. One child will die as soon as it comes out, and then when another child can die when they after completing +2. Don't laugh. I'm not mentioning about you. And another child will die at the moment the marriage function is over. Don't laugh. And then another thing is, if another child may die at the age of 60, another child may die at the age of 90. So 5 different child of a parent can die at any different point of time. The same way, in a given substance, the atoms which decays first will have a 0 lifetime, correct? The atoms which disintegrates finally will have an infinite lifetime. So the lifetime of an atom in a given radioactive substance will vary from 0 to infinity. So how to get a mean life? Takes few number of atoms, calculate the total number of lifetime of those atoms, divide by number of atoms. So the mean life is equal to the sum of the lifetime of all the atoms by total number of atoms. So this is referred by tau. The derivation is not given in your book, but can be derived. The mean life can be derived as 1 by lambda. The reciprocal of the decay constant. The lambda is referred as a decay constant. So the reciprocal of the decay constant is proved as what? Yeah, mean life. So we have derived the T half is equal to 0.6931 by lambda. So which can be written as 0.6931 into tau, because tau is equal to 1 by lambda. So this is a relation between half-life and the mean life. So next we will move on to another topic called neutron discovery. In 1930, and Bothy and Becker, when they bombarded a lighter element, namely beryllium, with the help of alpha particle, unknown nature of a radiation was found, and those two scientists thought that those radiation containing is nothing but gamma particles. But later on, and Chadwick analyzed that the bombardment of beryllium by the alpha particle, and he concluded that the unknown radiation is nothing but a neutron, which does not have any charge. So this is the discovery of a neutron. And we have what are the properties of the neutrons? The listing of the properties of neutron can be asked in 5-mark questions. It's a very important 5-mark question. So neutron is a neutral charge particle, and also neutron is a constituent particles of all the nuclei except what? A proton. This is the first property. And then when the neutron is a neutral particle, can be used as a tool for penetrating most of the atoms. And then within the nucleus, the neutron is very stable, but outside, and it actually comes outside, and you just take the neutron and place it outside, that becomes instability. So it loses its stability, and so that it actually disintegrates by emitting a proton and then positron, and next one is called neutrino. So proton and not positron, and electron and a neutrino. So you can say, what is a symbol for a neutron? So I'll just write the equation actually carried out by the Bothy, Chadwick and Becker. So Be beryllium 4E9 is bombarded by alpha particle.